This recording is for Primary Math 1. We're working in the Challenging Word Problems book, pages 5 to 8, and the examples, the worked examples are on page 1 through 4, and I always suggest that you go over those, that you look at those, and often do them with your children. This one has a lot of words on it. Your child certainly is not going to be able to sit down and read it. Most first graders would not be able to sit down and read it on their own and make any sense of it, so that certainly involves you. But hopefully, by letting me say it to you, I can maybe even make it clearer, and I have some thoughts about how to take the information, make it a little bit more tangible for our little first graders to work through. So let's start on page 5. Number 1. We have the example of a wagon wheel, wagon cart, and this is wagon number 5, and so the wheels have a 2 and a 3 because it tells us the sum of the two wheels is going to be the number of the wagon itself. And so then it gives us a wagon that is wagon number 7, and it wants us to name the wheels. I always cross my 7s. That doesn't bug you, but it is easier for me to tell my 7s from my 2s if I cross it, is the honest reason that I do it. And it tells us, hint, there may be more than one answer. It's a great idea for your student to find all of the answers if they can, and just be thinking about the fact that all of these numbers can work together to give you 7. And then of course you could continue going, but if you do, you have the same pairs just in the opposite order that you had before. And to cross them like this, you have the same 3 and 4 pair, it's just which wheel has 3 and which wheel has 4 makes up the difference. And notice, by the way, that these numbers go straight down, 0, 1, 2, 3, and these numbers, I'm sorry, that would be up. 0, 1, 2, 3 goes up, 7, 6, 5, 4 goes down, because when you put them together, a 0 and 7 make 7, but if one number goes up, the other number has to go down, and so 1 and 6 make 7. And again it happens, and again it happens until you repeat. So those are the kinds of things in numbers that we want to make sure that our students see and understand. Number 2 gives us another example. Now our train has 2 carts, and each cart is going to have the same kind of an idea that the sum of the wheels is the number on the cart. So now our numbers have to work together. This number has to pull double duty. 2 is part of 3, and 2 is part of 6. So when they give us a cart with an 8 and a 1 on it, and they ask us to fill in the values, hint, there may be more than one answer. Something that I like to have my students, my kids think about is, we could call it the limiting factor. That's kind of an adult term. What are the options? Okay, the options are limited on this one. For example, 1 has 2 options. Either it's 0 and 1, or it's 1 and 0. It's the only way I can get 1. So I know that I'm going to have more than one option. There'll be 2 of them. If this wheel is a 1, then the other wheel has to be a 7. If the middle wheel is a 0, the left side wheel has to be an 8. There are 2 options, and sometimes it feels very overwhelming to think, how many options are there? Now this one's not very overwhelming, but sometimes we get overwhelmed with the number of options, and you can realize, okay, I have a limiting factor. I have some options that are limited. There's only 2 choices for this wheel. And once you identify your 2 choices, you can find the rest of them. So let's look at number 3. On this problem, we have 3 cars that are 8, 2, and 7. There are 4 wheels to fill in. Maybe that sounds like a lot to your student. Maybe it would help your student to ask them which one is the most limiting. And that would be the number 2, because 2 can only be 0 and 1, or 1 and 0. Good golly. Hopefully your first graders are smarter than I am. 0 and 2, or 2 and 0. It could be a 1 and a 1. And those are the only options. That's the only way we can get 2. So then we can fill in the other gaps. If this, let's call it the blue wheel. If the blue wheel is 2, then the other wheel is 5, or 7, or 6. If, let's call it the pink wheel, is 0, then I have 8, If it's 2, I have 6. If it's 1, I have 7. So I have 3 options for my answers on this one, and I was able to find all of them by finding something that is limited and using that information. So that really helps me out to organize my thinking because, again, we want to take a lot of information, and for a first grader, that's a lot of information. Organize it, be methodical, right, and then work out solutions. That's what we want to do. And so that process of deciding where to start is very important. Number 4 is a similar kind of a problem. You have to know how to start, and the book has a method that it shows, and there's a lot of thinking involved. I think many of first graders are going to need a little bit more tangible something, so I would suggest that you take some 3x5 cards or scraps of paper or whatever and actually physically write the numbers 1, 2, 3, 4, and 5 on them, and let them actually use those numbers. The question here is that I want 3 numbers that I can fill in, and they're going to have a sum of 8. And I'm going to fill in 3 numbers in this direction that have a sum of 8. So the question is, how many different 3-number pairs can you put together that are going to have a sum of 8? Well, we could start, again, where do you start? It looks like when you start there's going to be an infinite number of solutions. How could I possibly find all of them? Well, let's just start, and let's start with the biggest number, because the biggest number kind of knocks some things out. For example, if I have a 5, could I have a 4 in that spot? And that answer is no, because that does not have a sum. That already has a sum of 9, and I have to have another number. Can I have a 3 in that spot? No, I already have a sum of 8, and I don't have a 0 card. So I could put a 5 and a 2 there. That's 7, and the only other number I could have is 1. So if you have one of your numbers as a 5, I only have one grouping of numbers that will work. And again, by putting down your 5 flashcard and putting numbers down here and deciding, you can decide what works. So then get your 4 flashcard out and put it down. Now we don't have to go back up to 5 because we've already found all of the options for 5. That's the nice thing about starting high, is you're working your way down to the lower numbers to figure out which ones will work on that. And so with the 4, if I try a 3, 4 and 3 is 7, and I can put a 1 down there, and that would be an 8. So that works out. What if I have the 4 and I put a 2 next? Well, 4 and 2 is 6. What I need is another 2, but I don't have another 2. So the only one that I can use that's going to start with the number 4 is this option. Okay, so then the question is, what if I start with the number 3? Now remember, I've already used up the 4 card and the 5 card, so if I start with 3, the only option I have is to use a 2 and a 1, and that doesn't work because it doesn't equal 8. So we have taken some flashcards and been very concrete about it and put numbers down trying to find the sum. Sum is another word for add. We want to add them together and get 8, and these are the only options that we find exist. So here's the point that we need to notice next. Both of them have a number 1, and so if the number 1 is going to go into my answer set, it's going to have to be in the middle. And then from there, I could make it 3 and 4, or I could make it the 4 here and the 3 here. And I have to make it 2 and 5, but it doesn't matter what order I put that in. And for that matter, I could put the 2 and the 5 here and the 3 and the 4 on the vertical side. So there's a lot of options to write it down, but any way you do it, you're going to have one line that is the numbers 5 and 2 and 1, and one line that is the numbers 4 and 3 and 1, and those count in this case as one answer, one solution. Now, when they look at this, You can see another method, another thinking skill in the book, and I don't say that mine is better than theirs necessarily. It is a little more concrete because I'm using some little flashcards as opposed to just mentally, but they have on page 4, page 3 and 4, they have an entire process by which they're helping you think through what that is. Page 2 even does the same thing. So look those over and consider those. And let's try again. We'll just do it again. And again, my point is that I'm just going to demonstrate it for you. Maybe 4 was easy. For some reason, 5 is hard. So let's just talk about this one. And this time, we're trying to find a sum of 10. This particular picture happens to be on the diagonal. It doesn't matter. We still want to find a sum of 10. Well, we have 3 numbers again, starting with the biggest number. Because that'll help us rule things out. Actually, you could start with the smallest number and it would work just as well. Simply because, maybe we should start with the smallest number this time to demonstrate it. 1 and 2 make 3. To get 10, I need 7. And I don't have a 7 card, so 1 and 2 don't work. 1 and 3 make 4. I need 6. I don't have a 6 card, so 1 and 3 doesn't work. 1 and 4 makes 5. I do have a 5 card, and that is one of my solutions. Another thing, by the way, to make this very practical would be to take a piece of paper and put 10 stars or 10 circles or 10 squares, whatever they want to put 10 of, and look at that and say, well, if I have 1 and I put 2 more, then I need 7. I don't have 7. Well, then let me put, instead of 2, let me put 3. I still need 6. That doesn't work. Well, then let me put 4. I need 5, and that does work. And so then we can go back, and if you've got something you can erase on or something like that, then since you had 1 for your first one, and 4 was the first one that worked, I could put a 5 next, but I'm out of numbers. I don't have anything I can put for that last spot. So to have the number 1, I only have one option. I can do the exact same thing and think about 2's. If I use 2 stars, now remember I only have the number 2. I'm not going to go back down to the number 1. I could go up to the number 3. So if I have 2 stars and 3 stars, then what I need next are 5 stars. Can I do another one with 2? If I have a 2 and a 4, that's 6. What I need to make 10 is another 4. I don't have 2 4s. And of course, if I have a 2 and a 5, then the last number is going to be a 3. Let your students see that too. The problem is if I have 2 and 5, the last number is 3, and really that's a repeat of what I did before. My numbers need to continue to go up in order for this to work. Okay, what if I start with the number 3? Well, 3 and 4 are 7. The next number would have to be 3. I can't do that because I've already used a 3. And again, coming over here to your numbers and saying I have 3 and I have a 4. What I have is 3 left over, and I can't use the 3 again. And so we see very quickly that I've used up all of my options. The 2 that I found here are the only ones. The number that is repeated is a 5, so that's going to go into the middle. And one of my lines is going to be 1 4 5. One of my lines is going to be 2 3 5, and it's not going to matter which one I put that on. The next one is number 6. We're just doing more problems. We're increasing the difficulty level really just because the number that we're dealing with for the sum is a different number. This time our number is 11, and this time we have the flashcards with the numbers 2, 3, 4, 5, and 6. So if you didn't see the others but you tuned in for this one alone, my suggestion is you make little flashcards with scrap paper or 3x5s or whatever with these digits on it, and let your child line up the ones that have a sum of 11. Now I said a while ago if you start with the biggest number, that can be a little bit easier. We're going to have 3 numbers in a line. Of course 6 and 5 make 11, but I have to have a third card. 6 and 4 make 10, but I don't have a 1 to make 11, so that tells me that 6 and 3 is 9 and 2 makes 11. So that's the first one, and that's the only one I can do with 6. Again, the point is to be methodical and to find solutions using a very well thought out plan that you can continue on and in the methodicalness not lose a solution. If I start with 5, I only have one 5 card, so that one's being used. I've already used 6 as much as I can, so for 5 I'd have to go down to 4, and that gives me 9. I need 2 more to get 11. Again, if you start out with a piece of paper that has 11 somethings on it, circles, squares, whatever, then you can physically look at what 5 of them look like, and then if you have the number 4, then you have 2 left, and you can actually use that. You could, if it's a whiteboard or something you can mark out, that'd be lovely. Do this in ink, and then mark on it in pencil and erase the pencil. That's a good idea too. Several ways to do it. If we wanted to try 5 again, 5 and 3 is 8. We need a 3 to make 11, and the problem is that we can't use the 3 twice. There's only one number card that has a 3 on it. So then can we use a 4 and a 3 and a 2? 4 and 3 is 7 plus 2 is 9. That one's not big enough. And remember, we don't ever go bigger than our number. We only go smaller because we've already used a 6 as many times as we can. We've already used a 5 as much as we can. So we don't have the ability to use a 4. It means the rest of the numbers are too small as well. And what we can look at this and see is that the number 2 is the one that is used multiple times. So 632 is in a line, and 542 is in a line. It doesn't matter which ones you put the numbers in, as long as 6, 2, and 3 are in a line. It could be 6, 2, 3. It could be 6, 2, 3. It could be 6, 2, 3. As long as you have 6, 2, and 3 in a line, it'll add up to 11, and so will 5 and 4 and 2. Number 7. All right, now the hard thing is that if you're tuning in on just the ones you're having trouble with, you have missed some instruction on how to do these and set them up a little differently than the book did, and so possibly going back and watching some earlier problems would be good. On this problem, this type of problem, what I suggested was setting up flashcards with the 2, 3, 4, 5, and 6 on them, or just a 3x5 cards, whatever, and to line them up in groups that give you a sum of 13. So if I were doing that, and I like to think in terms of starting with the biggest, if I start with a 6 and then I use the 5, that makes 11. What I have left that I need is a 2. If I did that again and had 6 and 4, that's 10, then I need a 3 to make 10 and 3 be 13. But if I used the 6 again and went down one more, 6 and 3 is 9, I need a 4, but wait a minute, 6, 4, 3 and 6, 3, 4, that's the same solution. So I don't have to have that one. And then if I tried 5 and 4, that's 9. And the problem is I need a 4 to make 13. But again, that is repetitive. I don't have 2 4s that I can use. I just have the 1 4. And if I went all the way down to 4, of course 4 and 3 and 2 would be the biggest I have, and that's just not big enough to make a sum of 13. So these are the two options that I have. 6 is going to be in the middle because it's used in both of them. So if it's 3 and 4 and 6 and 2 and 5 and 6, again, the order does not matter. Where you put them in the diamonds, which location doesn't matter, as long as the 3, 4, and 6 are in a line and the 2, 5, and 6 are in a line. Last problem. Probably I've lost my entire audience because you figured out how to do it by now. That's okay. Maybe you're just turning in and looking to the hardest one, and that's okay too. My suggestion has been to make 3x5 cards or scrap pieces of paper with each of the numbers on it so that you can tell, so you can put them down and actually put them in a spot. And we're trying to find the sum of 14. And so again, another suggestion that I made, by drawing 14 items, maybe even especially with ink on a piece of paper and then using pencil to mark it, it might be an easy thing to try and figure out, and I'll show you what I mean. So if I'm trying to find three numbers that add up to 14, I would start with the biggest just because it helps me to organize it quicker. 7, this would represent 7 of them. If I put the next biggest number here, that's a 6. If I already have 6 of them, then what I need left is 1, but I don't have a 1 number card, so that one doesn't work. I can't put the 6 with the 7. The next thing I would try, the next number down is a 5. That's 12. We can see that I need a 2, but again, I don't have a 2 in my particular number of cards. It would work if I had one. So 6 didn't work, 5 didn't work. If I use a 4, 7 and 4 leave me with 3 left over. So 7, 4, and 3 make a number bond that equals 14. Now I can't go any lower than 4 because if I did 7 and 3, I'd be out of options. So my next set of numbers, I've tried all the 7s. I'm not going to use 7 anymore. I've used it as much as I can, and that was only once. So now I'm going to try it with 6s. So instead of having my 7, I have 6. I'm not going to use the 7 again, so 7 and 5 make 11. You could draw that over here with your 5. And what I have left that I need to fill is 3. Now since I had to use the smallest number, if I went any smaller, if I did 6 and 4, that's 10, I would have to have another 4, right? The logic of that, they could certainly draw that out and see. If I used 6 and 4, the problem is I would need 4, and I only have one 4 number card. You can't reuse a number. So I've used 6 as much as I could because 6 and 5 worked, but 6 and 4 didn't. And 5 and 4 and 3 only adds up to 12, so that's definitely too small. In this problem, what I have that's the same is the 3. So the 3 will go in the middle, and one row will be 3, 4, 7. One row will be 3, 5, 6. Any order, doesn't matter. That will solve those problems, and it's just fun with numbers. Right? I'm just thinking of it as number games more than a math problem, math puzzle, math fun. Okay? All right, so that's the end of this week's Challenging Word Problems assignment.